Good evening. This is a smart lighting group. I am Humberto. This is Ramin, Shin, and Zia. So what is a smart lighting system? Basically what the smart lighting system is, it's a smart switch that allows any appliance that's hooked up to it to be turned on or off using a phone application, a smartphone application, or using our webpage. So what's the main concept that needs to be understood for this project to be a success? Basically, the main concept is to understand how the internet works. The way an internet works is when a web page is created, it's stored on a server that's directly connected to the internet. That server is designated a unique IP address. For example, Google and Yahoo has their own unique IP addresses. So, but when a person tries to connect to the internet, they don't directly connect to the internet. They use the internet provider, for example, Time Warner or Verizon, to connect to the internet. So when you try to connect to a web page, it sends a signal, it goes through traffic through different IP addresses. For example, your router has its own IP address, your computer has its own unique IP address. So it travels through the internet like that. So if we know the IP address of the web page, and we know the IP address of our router and our switch that's connected to the Wi-Fi, then we can send a signal to that switch when we want to turn on or off that appliances, no matter where we're at. This is a diagram that shows a quick diagram of how our system will be connected. Basically, we have the smart lighting system that's connected to the outlet, and whatever appliance you want to hook up will be hooked up to the smart lighting system instead of being hooked up straight to the outlet. So if a person goes to work and they forgot to turn off their light, they can check the status of the light and check if it's on or off, and if they wish to turn it off or on from a different location, they can do so using the web page or using a smartphone application.
So this is the competing product to our senior design project, and what this is a remote inside switch made by Belkin. So this is capable of telling the status of an appliance to the user as well as the power consumption, and the users also have the ability to turn on or off the appliance whenever it's needed. Also, it also has a schedule where you can keep time, where you can actually tell the appliance to either turn on and at some other time tell the appliance to turn off. Now, it sounds good and all, but the rating for this product is actually very low. We have a lot of complaints from the users and the customers. And one of the biggest concern for this product is that the product consistently drops out of the wireless network. So because of that, the users are forced to go ahead and reset the device with the appliance over and over again. And this caused a frustration, which actually, within a month, they actually returned this product. And the second one is that the switch is unreliable, and sometimes it shows up as not detected, although it's connected to the appliance. So this is one of the biggest concerns they have for this, the user have for this product. So our goal performance for this, for the senior design project, is to be able to provide a reliable wireless network so the customers or the users can actually switch on and off whenever they want. And also, our goal is to have a web page so you can actually control the appliance as well as a cell phone application. So they can actually decide either to use a web page or a cell phone app to control their appliance.
Specifications of the smart lighting system include a web page with a graphical user interface, also known as a GUI, a relay switch, a microcontroller, a Wi-Fi module, a power supply, a standard 120 VAC 2-prong plug, and a standard AC 2-prong outlet. Along with this, it must also be able to check the on and off status of the lamp to see if the lamp is turned on or off. Some design constraints of the smart lighting system include having a limited budget of only $200 to buy all the necessary supplies needed for the smart lighting system, along with also having a time limit of only 6 months in order to complete the entire project. So these things will constrain the students from building the project. The structure of the smart lighting system will consist of a desk lamp connected directly to the smart lighting system, which will then be connected to a standard AC outlet. It'll also contain a website with a GUI and a smartphone application in order to function. The smart lighting system will contain within it a microprocessor, a Wi-Fi module, a relay switch, a power supply, a standard AC 2-prong plug, and a 2-prong AC outlet. The 2-prong AC outlet is used instead of the 3-prong AC outlet because the casing that we're using for our smart lighting system is plastic instead of metal, and therefore the safety prong is not necessary, which is what the 3rd prong is usually used for. The function of the smart lighting system is to change the status of the light from on and off from any location in the world. And it should also be able to communicate with the Wi-Fi router and send information regarding its status from anywhere at any time just by using Wi-Fi from the website and the cell phone application. Using the cell phone application and the website, the user should be able to determine if the smart light is already turned on or off. And based on that, they can decide whether or not they wish to change the status. The maximum load limit for the smart lighting system will be 100 watts, and this is because after researching the average wattage of normal lamps that we use on a daily basis, we found out that they have a load limit of about 60 watts on average, and due to this, we're making ours 100 watts to prevent any safety hazards from occurring. Our smart lighting system will also provide reliable wireless network so that any dropouts from the network can be prevented. And the user also has the choice of using either a cell phone application or a website in order to control the lamp and to control its status. So they can choose whichever one is more reliable and efficient for them.
The way that the smart lighting system should be powered was not specified by the sponsor. So we decided, since it's already being plugged into the wall outlet, why not use the AC power that's coming out of the outlet to power it? So that's what we decided to do, to create a power supply in order to power the microcontroller inside the smart lighting system instead of using batteries. So what are the key skills that we need for this project in order to be a successful one? One of the main skills that we need is we need to learn how to write web programming. We need to learn how to write HTML or JavaScript. We also need to learn how to write smart cell phone applications in order to use a cell phone app to turn on and off the smart lighting system. We also need to know something about circuit design and electronic components in order to build our protective circuit and our power supply. We also need to learn how to set up a server in order to set up our website, and we also need to learn how to program microcontroller, or the specific microcontroller that we pick, and the Wi-Fi module that we will be using. Once we get a working prototype, we will move on and use a PCB board, and in order for us to do that, we need to learn how to use a PCB design software such as Eagle. Also, we need to learn to write software to use a 3D printer in order to create our casing for the smart lighting system. Nazia, you will be responsible for learning about PCB developing software and about the 3D printer software. She will also, her secondary skill will be to learn about the microcontroller and the Wi-Fi module programming. And Shin Park will be responsible for learning how to develop a power supply and a protective circuit and how to develop a smartphone app. He will also, his secondary priority will be to help Nazia with the PCB developing software and the 3D printer software. Ramin will be responsible for learning about the programming of the microcontroller and the Wi-Fi module, and his secondary will be to help myself with the programming language for the developing web page. So this is our timeline for when we expect to learn these skills. Basically, we're gonna jump right as the summer semester starts. I will start, basically almost everything is gonna take, we expect it to take about 2 months. The HTML, JavaScript, the server setup, the microcontroller web programming, the power supply protective switch circuits. The smartphone application, we'll have to wait a little bit till we learn a little bit about how to program the website. And the PCB design software, the 3D printer software will be learned towards the end when we think we will have a working prototype ready to go.
All right, so the hardware components are power supply, relay switch, microcontroller, as well as the Wi-Fi module. So for the power supply, since the microcontroller and Wi-Fi module operate at a voltage around 3.6, something between 2 to 5 volts, so we need to use a voltage regulator to convert AC to reliable DC voltage so that we wouldn't damage the microcontroller or the Wi-Fi module. And we were using a relay switch. The Wi-Fi module will communicate through the router and through the internet to the cell phone application, and it provides information about the status of the on or off status of the lamp, as well as provided a platform for the user to control the status of the lamp so that the user can change, turn the light on or off. To remove the degrees of freedom in any design, we need to make choices. To make choices, we need to have decision matrices. One of the decision matrices that we made was for the Wi-Fi module. There are so many different products from different companies and manufacturers, so we had to figure out which one is the best choice for us to do this project. So we considered different products from different companies, and we looked at the certifications that they have, as well as dimensions of performance of their products. One of the dimensions of performance is the transmitter's power. Another dimension of performance is the receiver's sensitivity. These performance dimensions are really important because it will influence the interference and other parameters while communicating to the router. And we also consider the cost and dimensions. And as you can see, looking at the life cycle for the product, they're all new products from 2014 or 15. So using this decision matrix, we were able to decide to go with the Texas Instruments product, CC3200 module. It's a Wi-Fi module that comes with a microcontroller unit built on it. This is a good product because it comes with user development kits that help us complete this project.
So just like Nadia said, our constraint for the senior design is 6 months period. We have 6 months period to actually complete our senior design project. So we actually went ahead and divided the project schedule into 9 different phases. So the first phase will be learn and understand what we need exactly in order to design our senior design project. This also includes new materials such as Java, creating a web page, also learning how to create a cell phone application as well. So after we have some idea of what we exactly need in order to create our project, we're going to go ahead and start out and go ahead and set up the setup internet server. That's going to be our second phase, as well as creating a web page. And the third phase will be creating a smartphone application. We actually prioritized this because we felt that since this is a new type of subject that we're actually learning and trying to create, it will be difficult and it'll take a lot of time in order to finish this. So this will be our top priority in the beginning. And we believe this will take up to 2 to 3 months in order to complete. Next, after that, we'll go ahead and design and build the actual smart lighting system, the device itself. So we're going to go ahead and discuss what we exactly need, the components such as microcontroller, Wi-Fi module, relay switch, circuit protection as well, the power supply. We're going to go ahead and discuss exactly which components that we need, and we're going to go ahead and try to order those in order to and build the actual device. After that, we're going to go ahead and program the microcontroller and the Wi-Fi module so they can actually communicate and send a command to to the relay switch to either open or close so the current can flow to the appliance and turn the light on. And after that, we're going to go ahead and try to integrate the web page, cell phone application, and the smart lighting system together. So like I mentioned, we're going to have a web page and a cell phone app in order to go ahead and see the status of the desk lamp and be able to control it. So this integration step, I think it will take a long time in order to go ahead and be able to communicate with each other. So we're going to try to focus on this after we get all the components built. And the testing phase is where ideally we have everything ready. The integration is done, all the components are built, the device is ready to go. So we're going to go ahead and start out with testing it. We're going to try to see how long will it take for the device to respond whenever we send out the command, and how long it takes for us to get a response back to see the status of this one as well. And we'll go ahead and do a documentation, and this will start out in the right beginning to keep track of what we exactly did, any design changes, any components that we actually needed or used. So we're going to keep our documentation as well to write our final report.
Okay, what we have here is a task table to show you who's responsible for what task. So Humberto will be responsible for setting up the internet server as well as creating a web page, and he will actually be responsible in doing this task itself. And he will also support the integration between the smart lighting system and the web page. And for the components, programming the components, Ramin will be responsible for that and doing the actual task. So he will try to go ahead and program the microcontroller as well as the Wi-Fi module. And he will also, Humberto will actually inform Ramin about the integration, about the web page to let Ramin know when to get started as well. So what you see right here is the responsibility, task, support, and inform to give you how this is handled. And I will be responsible for creating a power supply as well as a switch circuit protection, also creating a cell phone application in order to go ahead and integrate the cell phone app with the smart lighting system as well. Nazia will be going around a lot of places. She'll be supporting Ramin with the program, also as creating a box for a casing for the smart lighting system, as well as building a PCB. And she will also support the programming of the Wi-Fi module and programming the microcontroller, also helping me with the cell phone application as well.